In this video, we are going to learn the energy conversion that takes place within a vibrating spring. The energy conversion concept that you are going to learn will enable you to apply to any kind of systems.
If you are holding the weight and not letting it hang freely, not stretching or compressing the spring, there is only gravitational potential energy. If you exert a force to compress the spring, the weight gains gravitational potential energy as it moves to a higher position. The force that you exerted to compress the spring causes a transfer of energy to the spring, which gains elastic potential energy stored in the spring. If you stretch the spring, the gravitational potential energy is reduced because of a lower position. The force that pulls the spring effects a transfer of energy to the spring, causing it to gain in elastic potential energy that is stored in the stretched spring. If you could stretch the spring until the weight touches the ground, the gravitational potential energy is reduced to zero at ground level and the elastic potential energy increases because of the extended stretch. If you release and let the force of gravity pull the weight down, the spring will start to vibrate. What causes it to vibrate and eventually stops? It is because of a conversion of energies. Let's examine this in detail. As the spring vibrates between point P, the highest position, and point Q, the lowest position, we shall divide each cycle into 4 stages. From the top, point P, to the center of vibration, then stage 2 from the center of vibration to the lowest level point Q. Then stage 3 is the upward direction from point Q to the center of vibration, and finally from center of vibration back to point P. The vibrating spring system consists of 3 types of energies: elastic potential energy, gravitational potential energy, and kinetic energy. Throughout the 4 stages of motion, the energies are mainly transferred or converted among themselves. Due to air resistance, some energy may be lost to the surrounding as heat and sound energy. The total energy of the system shall be indicated by this last column. In stage 1, when the compressed spring is released, the elastic potential energy stored in the spring is converted to kinetic energy, enabling the spring to return to its neutral position. This causes the weight to move downwards. Since it is moving downwards, the gravitational potential energy has to decrease. Where does this energy go? It can only be converted to kinetic energy. It will not be converted to elastic potential energy because the spring is moving from a compressed position to a neutral position. It is releasing the elastic potential energy to kinetic energy. Some of the energy are also lost to the surrounding as sound and heat energy because of air resistance. When the weight reaches the center of vibration, the kinetic energy is at its maximum. All the elastic energies have been converted to kinetic energy as the spring is at its neutral position. In stage 2, as the weight continues to go beyond the center of vibration, there is the neutral point of the spring gets stretched. This causes the elastic potential energy to increase. The increased elastic energy comes from the conversion of gravitational potential energy as the weight moves to a lower position. The kinetic energy is also converted to elastic potential energy. Again, some energies are lost to the surrounding as heat and sound energy. When the weight reaches the lowest point at Q, all its kinetic energies have been converted to elastic potential energy. When all kinetic energies have been converted to elastic potential energy, the elastic potential energy now pulls the weight upwards. This pull causes the weight to gain in kinetic energy. Hence, there is a transfer and conversion of elastic energy to kinetic energy. At the same time, as the weight moves higher, it also gains gravitational potential energy. This means that some of the elastic potential energies are converted to gravitational potential energy. Again, some energies are lost to the surrounding as sound and heat. Again, as the weight moves up to the center of vibration, the kinetic energy reaches its maximum while elastic potential energy is reduced to zero. As the weight continues to move beyond the center of vibration, we go into stage 4. Now the kinetic energy is converted back to elastic potential energy as the spring gets compressed again. The kinetic energy is also converted to gravitational potential energy as the weight moves higher. At the highest point P, all kinetic energies have been converted and the stored elastic potential energy will again pull the weight downwards, bringing it back into stage 1. These vibration cycles will continue until all energies are lost to the surrounding as heat and sound. Now let's summarize the important points. Each time the spring is compressed, there is elastic potential energy stored in the spring. There is also gravitational potential energy because the weight is above ground level. Similarly, when the spring is stretched, there is also elastic potential energy stored in the spring. As long as the weight is above ground level, there will be gravitational potential energy. When the spring is oscillating, there is energy conversion from elastic potential energy and gravitational potential energy to kinetic energy and vice versa. At the center of vibration, the spring is not stretched nor compressed, so the elastic potential energy is zero. All the elastic potential energy has been converted to kinetic energy. Kinetic energy is at its maximum at the center of vibration. As the weight moves upwards, the kinetic energy will convert back to elastic potential energy and gravitational potential energy. At point P, kinetic energy is zero, having converted to elastic potential energy and gravitational potential energy. At point Q, kinetic energy is also zero, having converted to elastic potential energy. Notice that as the spring vibrates, more and more energies are converted to heat and sound energy. When all energies are eventually converted to heat and sound, the spring will stop vibrating. Hence, we say that the energies are out of the spring system and lost to the surroundings when they are converted to heat and sound energy. Note that the energies are merely converted and not destroyed. Total energy remains a constant because energy cannot be created or destroyed. It can be converted from one form to another or transferred from one body to another, but the total amount remains constant.